So we'll quickly look at our local area network. As I said, your local area network, just as the name depicts, it's a network within a specific localization, a specific perimeter or space. Now, it consists of few devices, um, and it can range from just a few devices to a network across multiple buildings. All right. So, I mean, depending on where you work, I mean, if you have several branches, you find out that each branch can have different local area networks. And if you need to communicate with your other branches, it will be extended using either through your wide area network and other network devices to ensure that you can communicate across even longer distances. So we'll talk about some of those as we proceed. Now, as the size and scope of the LAN increases, the importance um, to plan I mean, your logical configuration also increases. So, I mean, I recall, I mean, I think I mentioned it when I met with us the first time. My first IT certification was CCNA, and then further did CNA security. So, I mean, one of the first things we did was how do I share files? I mean, that was before you could actually drop files with Google Drive and other things. They were not big when I did my networking then. So you need to think of how to crimp your RJ45 cable, um, crossover cable, and so that you can share files by connecting cable from one laptop to another laptop, and then you would share a folder and you can transfer things over there, right? And so, I mean, when it's a one-to-one, I mean, I don't need to think too much in terms of configuration and all of that. But as the number of hosts and number of devices on the local area network increases, you need to also plan on the logical configuration. How would you partition your network? Will you assign IP addresses by virtue of the floors or of the building, or IP address will be assigned to departments, which means that maybe a department is sitting in a particular area, so they have their own router and they have their own switch, and then the IP address assigned on that level is different from the IP address on other, or are you going to create a virtual LAN and all of that? So the more devices you have, um, the more important it is for you to plan your networking. All right. And I mean, you see a lot of gaps when you go do network audit because sometimes it seems as if those who were saddled with the responsibility just did what they like, and because they know nobody knows much more than they do, and they just do the bare minimum, which puts us in a very tight corner as an organization. All right. So to set up a LAN, an enterprise must assess the cost. You look at the speed, you look at flexibility, you look at reliability. Now, issues it could include how do you access the media from physical transmitting data? What's the method for um, the physical network medium? I mean, how we need to be able to understand how data will be transmitted across the network and how the LAN will be structured. So when we're talking about the LAN structuring, we'll be looking at, okay, is it going to be a star layout? Is it going to be a ring topology? Is it going to be a bus topology? So those are, I mean, some of the things that you think about when you're doing, when you're building a network, right? Now, as this course is not specialized on networking, I can assure you for sure that nobody is going to ask you how to configure your network environment. And I know that last week, yeah, when we were doing the domain 5, I pointed out to us that when you're going through the manual, take note of the notes in the textbook because it tells you what ISACA would pay attention to. And I use the example from domain 1 where we're talking about the ethics and ethical practices of an IS auditor. It covers several pages, yes, but you need to know it, but you will not be tested about it. All right. So if you know those things, it helps you to know areas that you should pay attention to more and areas that you know that, oh, there is likely going to be a question from here. All right. So the goal for us is not just only to pass the exam, but also to gain knowledge. So it's good for us to be able to know, I mean, where those lines are and play around it properly to get the best out of this course. Now, so when you talk about the physical media specifications, you can have for the media side, you can use your copper twisted pair circuit, and I think that's when I was telling you when I started my networking. When you want to send files from one system to another, so you had these copper wires that you would crimp in an RJ45 to be able to share files. And most of us still have those network cables in our offices, even though there's been a widespread of the wireless or the radio systems, which is your Wi-Fi. All right. So today in the office, like me, when I go to the office, we I most times I'm connected on the wireless network, even though the network cabling is still available. All right. So you find out that both the copper twisted pair, the wireless radio systems, they work hand in hand. Now, on the fiber optics media, it exists in most organizations, and most times that's what is used for connecting lands across wide regions. All right. It also could also be what is used to get internet data to your network environment for you to be able to access the World Wide Web. Okay. And so it's a different type of media, fiber optics. All right. And so these are just the different types of local area implementation of media. Now, when we talk about topology, we're talking about the layout. Now, so your LAN topology defines how your networks are organized from a physical standpoint. All right, not logical. And I think in the previous class, we've always said we need to pay attention to that word physical and logical. When we talk about physical, it's something tangible, something we can see. Logical is intangible, invisible. I mean, you can give it whatever name. So when we talk about our LAN topology, we're actually looking at how the network is organized from a physical standpoint, whereas protocols define the information transmitted over a network is interpreted by a system, how the information is transmitted. So when I tell people, when we talk about protocols, I say, think about language. When we say network protocol, I mean, such as TCP/IP, I mean, transmission control protocol or slash internet protocol, it's a language. All right. I'm in a country where English is not the first language, which means I need to learn another language, even though I can still work with English language. All right. But then communication, if someone is speaking, say, Swedish language to me today, if there are words I don't understand, a lot of things will be lost in translation. So when you see the word protocol, think about language. If we speak the same language, um, what you mean would be what I understand. But if we don't speak the same language, what you mean might be misunderstood by me. Okay, so when we talk about the LAN topologies, we have three major. You have the ring, and you see that you have a concentrator. It's called a concentrator. This blue bulb at the center is a concentrator for the ring. And the process with which this actually works is you're passing a token ring round from one PC to the other. Now, in the star topology, you have a hub or a switch. Now, um, your hub or switch, most of us have seen it. All right. That's where you have a lot of ports, and then put pass in your cable, and all the systems pick from that place. And if you distribute it well, it will look as if it's a star. All right. So physically it looks like star. All right. But it uses this CSMA CD. All right. But your switch uses the CSMA CD, which avoids data meant for one PC going to another. But for your hub, when it receives a pack, um, a frame, because I mean your layer two data is called frames, right? Layer three is when you talk about packets. and that deals with IP address and all that. We'll talk more on that. But when it receives, let's use the word message. When it receives a message for a hub, it sends the message to all these six pieces connected to it and say, I got this message from ABC. Who owns this message? If PC1 says I'm the one, then it knows that the message for PC1. Subsequent message will send directly to PC1. But for switch, um, your switch would has a content address memory called CAM. So it has an address mapped to each port. The MAC address is mapped to each port. So it knows that if I see this MAC address in this message, it belongs to PC1. If it's this, it belongs to PC2. But that's just to talk about that. Then your bus is like one straight trunk of cable and everybody is plugging into it. So it looks like a long train or a long bus. So as we said, from the topology perspective, it's actually mimicking the physical, how it looks physically, all right? And one of the downside for the bus is if the major trunk is down or it's caught, then everything you're unable to communicate with other parts. And the downside for the star is if the hub or switch is down, all the pieces can communicate with each other. So they all have their benefits and demerits. Now,
So,
okay,
sorry, I want to ask
yes,
the
yes, feel free.
previous slides before this one.
Okay, yeah.
The ring, the boss, and the star. Is there another one, like is it mesh or merge or what?
Mesh, yeah, you have mesh. You also have something called mesh. All right. So, but these are the three major topologies that you have. So you're correct about the mesh also. So mesh is also another LAN topology.
Okay, thank you. I just want to confirm.
Okay. Because I think the major thing about mesh is just that unlike this one that okay, you have concentrators for the ring and star, and you have the bus. You have a major trunk for the bus. The mesh is like as though you are mapping each PC to each other and crossing, so it forms like a spider web of some sort. So it's just a network design where all your nodes are interconnected directly, either dynamically or hierarchically to one another. So you do not have a a central device that manages those interactions. So it's just like as I am now, I I let's just use LinkedIn, for example. All right. I'm on LinkedIn. I connect to each one of you. Then Derisola is connected to Damilola. Damilola is connected to Emmanuel. Emmanuel to Ferromi. So, if I want to get to Ferromi, because I'm not directly connected to Ferromi, I'm connected to Derisola. Through Derisola reach Damilola, and then reaches out to Emmanuel, then Emmanuel would reach out to Ferromi, ask Ferromi about the question I'm asking. Ferromi sent it back that way. All right. And I can also be connected to everybody directly. So instead of asking Darren Solar, then Damilola, Emmanuel, then Ferromi, I can go directly to Ferromi and Ferromi can come directly to me. So it depends on how the mesh is designed. It's not a practical stuff you see in most environments. All right. It's not something you would see in most environments. So you can have a full mesh, which means that a full mesh, everybody is connected to everybody. All right. But for your partial mesh, only the critical or peripheral systems are connected to several others. So if I am like the critical asset for this thing, all right, a partial mesh is where I'm connected to you, to all of you, but then each one of you is connected to at least one person. So that most times, if you need to get from one place to the other, you might need to come through me, then to get to somebody else, or get through two or three other persons to get to the person you want to get to. I hope that clarifies. So,
Yeah, yes, but what if they ask us which one is the best out of ring, star, boss, merge? What are the criteria to see, Abi, to how are we going to know the best?
So the way the questions come, I know they always ask questions around best, but no, I've not seen a question where they ask you which of the topology is best. Now, but if you're to choose based on criteria, you need to understand each of the topology, right? I mentioned some of the downside of star. I said for the star topology, if the hub or the switch is down, then all communication goes down. You can't reach out to anybody. For the bus, if the trunk is cut, let's say on the point between the PC2 and 3, then PC1 and 2 can still talk, but they can't reach out to PC3. Then for the ring, if the concentrator at the center that handles the um, token sharing, all right, the token that is being passed in the ring, if that concentrator is down, everything is down. Now, for the mesh, because the mesh, I mean, it's also going to depend on what kind of mesh. If you're looking at it as the full mesh, which means everybody is connected to everybody, then you would say that mesh would be the best practically in terms of availability. So when we talk about best, I mean, we need to put into context of what the question is saying. If the question is talking about a high availability environment like healthcare or banking, then I mean you can go for the mesh. But then you also look at it in terms of cost. I mean, if everybody is going to be connected to everybody, that mesh architecture will be the most expensive. Do you understand? I mean,
Yes,
for sure, yeah, yeah.
but I saw
So
something like one of these official Q&A. That's why I'm at.
okay, no problem. But if you have that question, you can just share it on the WhatsApp group. We look at it together. But when you're choosing such answers, I mean, the reasoning I just gave you are the things you look at. You look at what are the benefits and what are the demerits for each of the topology. You have both those merits and demerits, and then you weigh it against the context of the question. Most times it won't just ask you which is the best between a ring star boss. It would have told you a little story that you're an IS auditor in a pharmaceutical industry or in a healthcare industry, and your services are critical to saving life or something, something. It will tell you a story. So we need to pay attention to that story to be able to know which solution will be best for that scenario. And that's why when we started, one of the things I mentioned to us is um, the most expensive solutions are the most technological advanced solutions are not always the best solutions. Solutions have to be tailored to the overall organizational objective. So when you see questions like that, I mean, beyond the technical jargons that you see, you need to be able to understand those technical terminologies and all. But you need to also put it in context of the organization in question, the scenario in question that's being presented to us. Okay. All right. Felicia, I don't know if that answers the question.
Perfectly. Thank you, sir.
All right. Thank you very much now for that question. Really appreciate that.